to the power minus 2. But
Minus of x to the power minus 2. Huh?
yeah, minus of x to the power
Okay, fine.
minus.
Okay. Your calculations are good. The rest of the things I will check during the class. So, Kinza,
Yes.
you want to prepare just for your CBSE exams, or along with CBSE, you have some target of JEE? By the way, you are Indian or you're from any other country?
No, no, Indian, sir.
You're Indian. So, you want to prepare for JEE and NEET as well?
Yeah, but I don't have a.
Okay. Okay, fine. Let's discuss that thing at the end of the class.
Yes, sir.
So, currently, we are doing this series and parallel combination of cells in the class. And the next topic that we will do will be the Kirchhoff Law. But to understand Kirchhoff Law, you should know Ohm's Law. See, Kirchhoff Law is an independent topic. It's totally independent topic of current electricity. It does not depend upon any other topic. But to understand Kirchhoff Law, you should know some basic things like Ohm's Law. What is Ohm's Law, Kinza? Kinza, what is Ohm's Law?
I don't remember the definition.
Okay, so no, I've never asked definition. You know the expression for Ohm's Law? See, Ohm's Law says that voltage across a conductor is directly proportional to the current. Or you can say other way around, that current flowing through a conductor is proportional to the voltage. Greater the voltage, greater would be the current, right? And when you remove this sign of proportionality, you use a constant R. So V is equal to IR. This is sometimes known as Ohm's Law.
Yes, sir.
From your class 10, I believe. Huh? V is equal to IR. Voltage is current multiplied by resistance. That's Ohm's Law. Do you know what are series and parallel combinations? So if I give you two resistors, I'm giving you one resistor of 2 ohm, another resistor of 5 ohm. I connected it with a cell of 10 volt. What is the equivalent resistance of the circuit, Kinza? What type of combination is this? 2 and 5. They are connected in series or in parallel?
Series.
Series. If they are in series, then how you add them?
1 by 2 plus 1 by 5.
No. That we do in parallel. In series, we add them up directly. So that will be 2 plus 5. How much is it? 7.
7, yeah.
If I ask you to calculate the total current, what will be the current in the circuit? Total current through the circuit. You can use this expression to calculate current. Think about it. So what's I from this equation? Get the value of I from this equation. How much is I?
Is equals to V by R.
Yeah, perfect. So it will be V by R equivalent.
10
How
by
much is
7. 10 volt, 10 by 7.
10 by 7. That's that. Okay.
Yeah.
Now, when a current flows, then some part of electrical energy also get dissipated in the form of heat. So we have some heat energy also. We have some power dissipated. Power dissipated means it's a part of electrical energy which dissipate as heat. You must have experienced this thing. Like if you say you have a fan, when current passes through the fan, when you switch out the fan and you touch your fan, after some time it gets heated up, right? Not just but any bulb. Even if you are using a bulb, if you touch a bulb, it gets heated up. So from where that heat energy is coming, Kinsa? Think about it. You're not heating that bulb, right? You just switch on the power, the current flows through the bulb and that bulb gets heated up. Bulb also glows, it also provides electric like light energy, but it gets heated up. So from where is that heat energy coming? Make some intelligent guesses. Okay, you don't even want to try, Kinsa, huh?
I don't know, sir.
Okay. Basically, the electrical energy which gets dissipated in the form of heat. When the current passes through your cell or your say your bulb have certain resistance. Due to that resistance, a part of your electrical energy gets wasted as heat. That's the heat energy, and which we call in circuit analysis as power dissipated. You got this thing?
Yes, sir.
So from where does that electric heat energy comes?
The power which is dissipated.
Which energy is dissipated as heat? It's electrical energy.
Electrical energy. Yeah.
Part of electrical energy which gets dissipated as heat.
Yes, sir.
That power, see, what is the relation between power and energy, Kinza? This you must have done in your class 11th. 11th and 9th. See, power is energy divided by time. That's it. If you take time to be 1 second, if you take time to be 1 second, if I take time to be 1 second, so if I put t equal to 1 second here, then can you equate power of energy? Then what would be the relation between power and energy?
Power to energy.
So what is power? Power is nothing but energy in unit time.
Yes, sir.
Energy per unit time is known as power, right?
Yes, sir.
So these are the things that we'll be using in today's lecture. So students are joining. We will start in 1 or 2 minutes. Start a lecture in 1 or 2 minutes. So for today's lecture, you will just need Ohm's law and this simple concept of power, like what is power. Then we will go. So maybe in the first 10 minutes, Kinza, you may not understand what we are doing because we will be doing a numerical based on the last lecture. After 15 minutes, we'll start a fresh topic, that's Kirchoff. So just have to take patience for 15 minutes.
Yes, sir.
Excuse me, sir.
Yes, Arpit.
So can you scroll up to that question, that storage battery wala? Sir, I have some doubt in it.
Okay, just give me 1 minute, Arpit. I'm writing a numerical, then I'll come back to you. Yes, Arpit. Which numerical? This one. This one, huh?
Yes, sir. Sir, sir, in this question, sir, but what will be, sir? Here it will be charging or discharging, sir. Sir,
Yes.
that was my question.
So you're confused about the charging and discharging?
Yes, sir. Yes, sir. That is getting very confusing.
See, when a cell charge, the direction of current is from negative to positive. Okay. When I'm saying negative to positive, that means it's through the circuit. Through the circuit, not through the cell. I'm not saying negative to positive in this way. That will be through the cell. Whenever we say the direction of current for a cell, we say it's through the circuit. So it's from negative to positive. So if it is negative to positive, that means your cell is charging. And if the direction of current is from positive to negative, that means your cell is discharging. So in this cell, the direction is from negative to positive, so it's charging. And here it's positive to negative, so it's discharging. Okay?
Okay, sir. Yes, sir.
Let's start the lecture.
So it's 8.
Okay, so let's start this thing. Huh?
So 1 minute.
So up to last class, we have finished this series and parallel combination of the cell. We did a series and parallel combination of identical cells also. So this is the question that's based on the last lecture. So before starting this question, let's recall some portion of the last lecture. So when we prefer series combination, Hishma, when we prefer series combination of cells, Hishma, audible. Hishma, where are you? Miraj, when we prefer series combination of cell,
So can you repeat the
Noha,
question?
yes, Miraj, you were saying something. When we prefer series combination,
Sir, what, sir? Can you just last time repeat?
so we did this in the last class. Now, when we prefer series combination, Yashika,
Sir, when the external resistance is large.
external resistance is large, then we prefer series combination. When we prefer parallel, Noha,
So when internal resistance is large, is going
internal resistance is large. And when we prefer mixed grouping, Miraj, again, when we prefer mixed grouping,
So it is parallel, sir.
parallel. I'm asking when we prefer mixed grouping. Arpit, when we prefer mixed grouping,
When current is max.
when
Current is maximum.
current is large. Unib, when we prefer mixed grouping,
Sir, when external and internal resistance are comparable.
When external and internal resistance are comparable, we even write these things explicitly. Like in series, we wrote this statement that we prefer series grouping if external resistance is large. We wrote that we prefer parallel grouping when internal resistance is large, and we wrote that we prefer mixed grouping when internal and external resistance are comparable, because we need maximum current, right? Is it clear? Arpit, Miraj, Ishma?
Yes, sir.
Now that's the question. This is based on the topics that we did in the last lecture. So you have 8 cells, each of 2 volt, and 1 ohm is the internal resistance. This 2 volt is the EMF of the cell. You have 8 cells. So you have to combine them to get maximum current in 3 cases. In the first case, your external resistance is 100 ohm. So the first part of the question, N is 8. EMF of the cell is 2 volt. Internal resistance is 1 ohm. How will you combine them? And external resistance is 100 ohm. Arpit, which case is this? Internal is large or external is large? Arpit, which case is this? This is case of
external is large.
External is large, right? So this is when R is very, very greater than small r. If external is large, then which grouping would you prefer? We have discussed this just now.
Sir,
Yes. Arpit, which grouping we will prefer if external is large? Arpit, just go through your notes and read that statement when we have mentioned when we
sir, series.
series. So we'll prefer series grouping. And not a small topic. Series grouping. So in series grouping, the relation for calculating current is this. See, this is the series grouping. Now.
NE by R.
NE by R is after approximation. This was the exact expression of current. NE by NR plus capital R. This is the expression of current, right? This is NE divided by NR plus capital. How much is N? Number of cells, it's 8. Which is E, it's 2. Again, N is 8. Small r is 1. Capital R is 100. So this is 16 by, it's 8 plus 100. So it's 16 by 100 data. Is it clear? Apit, Hishma.
Yes, sir.
Yes, sir.
Next part. So those who were absent in the last classes, please wait for 10-15 minutes. Let me finish this topic. After this topic, I will start Kirchhoff Law, which is a comparative independent topic. So we'll start understanding from Kirchhoff Law. So this numerical that we are doing is based on the previous lecture. Okay, so the next question is, your external resistance is 0.01 ohm. Your internal resistance is 1 ohm only. So this is, which case is this? Internal is large, external is large. Which case is this?
Parallel.
Your internal is large, right? Internal resistance is very, very greater than external resistance. So Miraj, which grouping would you prefer if internal is large as compared to external?
The parallel group.
Parallel
You
A is equal to NE by R, sir.
prefer parallel grouping. So in parallel grouping, the expression of current, see, this is parallel grouping, right? This was the expression of current in parallel grouping. ME by M into capital R plus small r. So this is current. It's ME by M into capital R plus small r. Anshika, what was M here? What was M in parallel grouping? Anshika, what was M in parallel grouping? Noha, what was M in parallel grouping?
They're identical cells in
Number
parallel.
of cells, huh? So the number of cells are 8. So it's 8 into 2 by 8 into capital R, which is 0.01, plus small r, which is 1. So you have 16 by 1.08 ampere. This is the correct. Let's start the third one. Your internal resistance is 0.5, external is 0.5 ohm. And internal, like all cases, your internal is 1 ohm. So which case is this, Hishma? Which case is this? Internal is large, external is large, or they are comparable?
So they are comparable.
They are comparable. So R is equal to, almost equal to. So when they are comparable, then which combination would you prefer? Vishma?
Mixed grouping.
Mixed grouping. And what is the relation for current in mixed grouping?
MNE by MR plus NR.
MNE by its M into capital R plus its N into small r. MNE by M into capital R plus N into small r. That is the expression. Let's do it. Now the issue in mixed grouping is you don't know the value of M and N. See, you know E, you know capital R, you know small r, but these terms are missing. You don't have any idea about N. You don't have any idea about N. These M and N are unknown. You don't have any idea about N. So to calculate M and N, you have two variables. So how many equations you need? Minimum number of equations? Two equations. If you have two variables, then you need two equations. See, so you need two equations in M and N. See, from where you will get these two equations? You will get these two equations from this. One equation is this, and R is MR. Another equation is this. Total number of cells are M into N. These are the two equations in M and N. Okay, now tell me. What is M into N here? Total number of cells are 8. What is M into N?
Equals to it.
M into N is total
Number of cell.
8, right?
Yes, sir.
That's your first equation. What is second equation? M into capital R is N into small r. That's how much is capital R? What's the value of capital R?
Sir, 1. It's equal to the small.
Seems only Arpit is in class. What about the rest? What is the value of capital R here?
0.5 ohm.
0.5. N. And how much is small r?
1.
1. So you have 0.5 M is equal to N. And how much is 0.5? It's half. I can write it as half. It's half M is equal to N. I call this as second equation. So what I can do is I can substitute 2 in 1. So when I substitute 2 in 1, I get M into M by 2 is equal to 8. I get M square by 2 is equal to 8. I get M square is equal to 16. I get M is equal to 4. M is equal to 4. Now you have M, you can easily calculate N. Your N will be, what's the relation between N and M? How will you calculate N if you have?
Sir, 8 equals to M into N.
N is M by 2, right? From this equation. So it will be 4 by 2. So your N is equal to. Once you have M and N, you can substitute these values here. Once you substitute the value of M and N here, you can get the value of current. So current is M, which is 4, N, which is 2, E, which is 2, divided by its M into capital R plus N into small r. M is 4, capital R is 0.5. N is, how much is N? Is 2, small r is 16. See, 4 into 0.5 is 2 and 2 is 4. So current is 4. So this is how we use those statements. Whether the current in the circuit is maximum or minimum, that you will decide using the relation between the capital R and the small r. Please note it down.
So can you show the question?
Minashi, Saifullah, where were you in the last? Minashi, you were absent for the last 3 weeks, I guess, huh? 3 weeks, huh?
Yes,
What happened?
I'm in India.
You are in India, vacation, huh?
Yeah,
Saifullah, you were again absent in the last class.
I was out, sir.
Nabil, you joined for 5 minutes yesterday and then you left. What happened? Nabil Khan,
Yes, sir.
what happened yesterday? You joined for 5 minutes and then you left.
Sir, I had an appointment. That's all.
You had an appointment with a doctor.
Yeah,
Did you went through the recording of the last lecture? No,
half of it.
half of it. See, if you are missing your class, just go through the recordings. Like in 24 hours, those recordings gets updated into your account. If the recordings are not getting updated in your account, just text on the official number, or you can text on the group in which you are. Can I scroll it now?
Yes, sir.
Note it down, please. Do it fast.
Written, can I scroll it over?
Yes, sir.
Okay. Saifullah, did you went through the recordings of the last lecture?
Sir, it is not updated in my account.
It's not yet updated. Just text that thing on the group, on the official number. Just WhatsApp that thing on the official number.
Yes, sir.
Sir, can you scroll?
Yes, I'm scrolling. Nabil, you are very late today. What happened?
My laptop was.
Okay. So you have missed one numerical, huh? The topic that we were doing yesterday, like series and parallel combination of identical cells. We have discussed just that numerical now.
Can you scroll?
You can go through the recording, huh? And still you have doubt in that numerical, we can discuss it after the class. See, after your class,
Yes,
I'm
sir.
free.
Yes, sir. I'll check it. Thank you, sir.
Minashi, try to be regular from now onwards. Huh?
Right.
See, the chemistry and biology are those subjects which you can learn by recording only. But this physics and mathematics, these are two subjects which need continuous discussions.
Can you scroll?
Yes, recorded lectures are not very beneficial for physics and this mathematics thing. The thing that you learn by discussions, by calculations. So try not to miss those classes. And Minashi, vacation for class 12 students, there is no vacations. The vacations will come after your entrance exams. See, it's a difference between India and this yours West Asian market. Like in India, in summer break, we have extra classes. We take extra classes of students. Like we'll try to finish a major portion. But in this West Asian, especially in Saudi and all, like students usually like for 40% of our students are on leave. They are on vacations.
Can you scroll?
Yes.
Sir, can you scroll up for a second?
Yes.
सर जिसमें वो आई वाला फॉर्मूला है yes
Okay.
sir हो गया.
Written everyone? Can we start the next
Yes,
topic?
sir.
So that was about series and parallel combination. Now just two more topics are left. One is this Kirchhoff law and another is instrument. So we will be starting Kirchhoff. So those who were absent for last few classes or Kinza, who's today's first class, from Kirchhoff law you will understand this is an independent thing. So let's listen some introduction of Kirchhoff law. See, for circuit analysis, we did various methods. We did series and parallel combination. We have discussed further many methods in series and parallel combination, right? Then we did series and parallel combination of cells. There are still many circuits which can't be solved using series and parallel combination of resistors, using series and parallel combination of cells. Means there is a good number of circuits which can't be solved using the series and parallel methods. You need something else. You need to go beyond this series and parallel combination. And those are Kirchhoff laws. Basically, those methods of series and parallel combination are not Kirchhoff laws. They're not laws. Series and parallel that we were doing are tricks only. So the issue with the tricks is they are applicable in some cases and not applicable in many cases. But when you have laws are applicable everywhere. So series and parallel that we did were tricks. They were applicable in some cases, but there are many circuits where you can't apply series and parallel combination. One example is unbalanced Wheatstone bridge. We did Wheatstone bridge, but I told that it is solvable only if bridge is balanced. If it is not balanced, then you can't solve it using series and parallel combination. Just like your bridge, you have other things also, like you have several other methods also, other circuits also, which can't be solved using series and parallel method. You need to go beyond series and parallel combination. series and parallel method, and those laws are Kirchhoff laws. Kirchhoff was a mathematician. He gave two laws for series and parallel combination. One law is based on the conservation of charge, that charge always remains conserved. That's the first law of Kirchhoff. The second law of Kirchhoff is based on the conservation of energy, that energy remains conserved. So these are two Kirchhoff laws. And if you know Kirchhoff laws, then you can solve each and every circuit. There is no circuit in physics which is not solvable by Kirchhoff. So let's start with the Kirchhoff. And your exams also of Kirchhoff law have a very good weightage. So there are two Kirchhoff laws. First is Kirchhoff current law. Or you can say this also as junction. This is also known as KCL. This law is based on conservation of energy, or sorry, conservation of charge. So see, you have this thing, you have few wires. Some current is entering from this wire, some current is entering here, and some current is leaving. This is the junction. So the Kirchhoff current law or Kirchhoff junction law says that current entering the junction is exactly equal to the current leaving the junction. Entering current is equal to leaving current. There is no loss of current across the junction. Current does not, current is basically charge. Charge remains conserved. So current entering the junction is equal to current leaving the junction. And how much is this entering current? You all please just unmute yourself. Yeah.
I1 plus I2.
I1 plus I2. See, I'm used to of a very interactive classes. So just unmute your mic. Don't worry about the background noise, even if it is coming, and participate in class, please. I1 plus I2, it's entering current, and how much is leaving?
I3.
I3. So entering current is equal to leaving current. See, if you listen my offline lectures, so it's a big batch and all are literally screaming. Like when I ask, all of them answers things. See, you don't just learn things by listening. You learn few things when you recall them, when you repeat them. So that's why I'm asking you to just unmute your mic, and at least it will help you to concentrate. So entering current is I1 plus I2, leaving current is I3. So entering current would be equal to leaving current. This is I1 plus I2 will be equal to I3. Let's take one example, or you can write this thing in one more way. So the first statement is current entering the junction. Current entering the junction is equal to current leaving the junction. So current entering the junction is equal to current leaving the junction. This is the first statement of Kirchhoff law. The same statement you can write in this way also. The same thing, but you can write here like algebraic sum of all currents at the junction is 0. So if you add up all currents at the junction, then they will add up to 0. That is the second Kirchhoff law. But while using this second statement of Kirchhoff law, you will use a sign convention. And that sign convention simply says entering current is positive. Entering current is positive. Means current entering the junction is positive. And current leaving the junction, leaving current is negative. Now tell me, which one is positive out of I1, I2 and I3?
I1 and I2 are
I1, I2
positive.
are positive
I3
and I2
negative.
I1 and I2 are positive because they are entering. I3 is leaving, so it should be negative. So you can write this as I1 plus I2 minus I3. The sum should be 0. So I can take this I3 to the right hand side. I1 plus I2 is equal to I3. See, I get the same thing. So these two statements are complementary of each other, same thing. Either
Sir,
you
what
write, yes.
Sir, what if the direction of current is not given, sir?
The direction of current is given. If it is not given, then you have to assume something.
Okay, sir.
Okay, then that is a variable in the numerical, but he will give you something else, some other data, so that you can decide the direction of current. So whenever you have a junction, the algebraic sum of all the current at the junction is 0. That means current entering the junction is exactly equal to the current leaving the junction. Is it clear, everyone?
Yes, sir.
Yes.
Kinza, Minashi,
Yes, sir.
Yes, sir.
Saifullah, clear. Okay. Alia, any doubt? No doubt. Okay. That was the first law. So in the first law, you get very, very basic type of questions. The questions like you have this type of junction. Some 2 ampere is entering, then 3 ampere is entering, 1 ampere is leaving. This is some unknown current I that you are supposed to calculate. Let's apply. I will always use this second thing. So 2 ampere, positive or negative?
positive,
Positive.
Positive.
3 ampere,
positive,
Positive.
1 ampere
negative,
Negative.
plus I, which is equal to 0. See, I is unknown, so don't put any sign over it. Keep it neutral, plus I. So 3 plus 2, 5 minus 1, it's 4 plus I equal to 0. And how much is I now?
Minus 4.
minus 4,
What does minus 4 means? Is it entering or leaving?
leaving,
Leaving.
Leaving. 4 ampere is leaving. Is it clear, the first law of Kirchhoff?
Yes, sir.
It's a very, very easy law. The current entering the junction is equal to current leaving the junction. And it is based on conservation of charge. Note it down, then we'll start with the second law. Second law is a bit tricky.
Done, sir.
Okay. Anshika, doubts?
No, sir.
Raj,
Yes, sir, it's clear. Just scroll.
okay. Ishika, what topic are you doing in your school?
So we're around the series and parallel combination of cells, like we started it.
Okay. Second, third chapter only. Okay. Arpit, and you? Third chapter only, na?
yes, sir.
Anshika?
So we started electromagnetic induction.
Started electromagnet, sixth chapter.
So actually पहले हमने first two chapters किए थे, फिर हमने electromagnetic wave वाला chapter किया, and then we started this one.
You did electromagnetic waves without current and magnetics.
Yes, sir.
School कौन सा है?
Suburban Valley Global.
हाँ?
Suburban Valley Global.
Like electromagnetic waves, na, it's the combination of all first 7 chapters. Whatever you are doing in all first 7 chapters, you will combine them up and that you will study in electromagnetic waves. Noah, you're doing magnetics?
Yes, sir. Cyclotron, chapter number 4.
Cyclotron. Miraj?
Sir, same, sir. Chapter 4 cyclotron.
Okay. Cyclotron is not in syllabus now. Are you doing cyclotron in school? Cyclotron is deleted from CBSE.
Sir, do you have the 12th omitted portions of
Yes,
CBSE?
yes. I'll share it on group. I'll share
Okay,
it.
sir.
Because some portions are being deleted and some portions are being added.
Sir, added portion means it's not there in textbook, or it's like
Added means all things are in textbooks, but they have deleted. Added means those portions were deleted in the last session. They were not
okay,
there in the last session's table, so they add those topics.
okay, sir.
Cyclotron is a part of deleted portion. They have removed this cyclotron from this. Even in current electricity, they remove potentiometer. I don't know why they remove potentiometer. Alia, you have finished electromagnetism in school, huh? Sab kadam, first book.
Sir, in the 3rd chapter, they're saying that resistance is not there. Does that mean
Yes,
like
yes.
law is not there?
Series and parallel is not there in your CPSC exams. But the issue is, I can't teach anything if you don't know series and parallel combination of resistor.
Okay, sir. Sir, and that, but Ohm's law is there, right, sir?
Ohm's law is there.
Okay.
If you don't know series and parallel combination, then you can't understand even the series and parallel combination of cell. It's tough to explain Kirchhoff law if you don't know series and parallel. I don't know how they delete the portions. They have deleted that potentiometer thing that is understable. Like potentiometer is a totally different topic. Yes, written everyone. Can I?
Yes, sir.
Sefula, you were doing chapter number 2 when your school's vacation starts, na?
No, sir. 4.
4 you were doing. Minashi, you were doing chapter number 4.
No, sir. 3.
3 you were doing. Ishma,
So chapter 4.
chapter 4.
Yes, sir.
Nabil Ahmed,
Please, sir. We just finished it. and-
Nabil Khan,
Sir, just started 3.
just started 3. And your vacations will be over by August end. Like your school will reopen from Sept first week, na?
Yes, sir.
Yes, sir.
Written everyone, can I scroll it over?
Yes, sir.
Okay, next is Kirchhoff's second law. Kirchhoff's second. Kirchhoff's second law is basically it's loop law or Kirchhoff voltage law. Kirchhoff voltage law or this is also known as loop law. The short form is KVL. We'll always write it as KVL. This is based on conservation of energy. The law says that algebraic sum of all voltages in a closed loop is 0. So if you take a closed loop and you keep on adding all voltages, then sum of all voltages is 0. That is Kirchhoff Voltage Law. So you can say that algebraic sum of all the voltages in a closed loop is 0. Now, before understanding this Kirchhoff Voltage Law, let's understand sign convention. I'll explain it later. But to understand Kirchhoff Voltage Law, you should know sign convention. See, what is sign convention? Here we'll use a sign convention which says rise in potential is positive. Rise in potential is positive. And fall in potential is negative. Rise is positive and fall is negative. This is the convention that we are using. Now see how we'll use this convention. Let's say you have a cell. This is the terminal of cell which is at higher potential. This is the terminal of the cell which is at lower potential. And let's say I'm moving from in this direction. This is the direction of my motion. Don't worry about this direction of motion from where it will come. Don't worry about this direction of motion. Just take it as ad hoc. I'm saying we are moving in the right hand side direction. So take it to be default that we are going in right hand side direction. Don't worry that from where this direction will come. That we will discuss in the numerical. So if you're moving in this direction, first the higher terminal comes and then the lower terminals comes. So Minashi, your voltage, your potential is rising or it's falling? First higher, then lower. It rises or it falls? Sorry, it's falling, right? So your EMF will be negative. If potential falls, that means your EMF is negative. This says rise in potential is positive and fall is negative. So if you move from high terminal to the lower terminal, this is fall in potential, we'll take for fall is negative. Let's take another example. Let's start this thing as this way. You're going here in this direction. First is lower terminal, then it's high terminal. It's rise or fall?
Rise.
Rise. You're moving from lower to higher. And always, and what type of convention this rise have?
Positive.
Positive, negative. So the EMF of the cell will be positive. E will be positive. We'll take that E to be positive. Another example, third. If I take a resistor and some current is passing through the resistor in this direction. See, this thing we have already discussed that current flows from higher to lower potential. So if current is flowing in this direction, that means this should be the higher potential and this should be the lower potential. Now, if I'm moving in this direction only, like I'm going in this direction. So in which direction I'm going, Kinza? In the direction of rise in potential, in the direction of fall in potential?
Fall in potential.
Fall in potential. So, and what will be the voltage drop across the resistor, Kinza? Resistance is R, current is I. What's the voltage drop across the resistor? We did it. Ohm's law. Apply Ohm's law, Kinza. Current is I, resistance is R. What is the voltage? Voltage if you have current and resistance. Ishma?
IR.
IR, it's IR. And it will be positive or negative, Kinza?
Positive. Sorry, negative.
Negative, it's fall. Let's take another example. This is the resistor. This is the direction of current. Means this is higher potential, this is lower potential, and I'm going in this direction. So Kinza, how much would be the voltage?
Minus IR.
Minus IR. See, you're going from lower to higher or higher to lower?
Higher to lower.
See, look at this arrow.
Sorry, lower to higher. Yeah.
So
Plus
it will
IR.
be plus IR. So this is how we'll use this convention. Rise is positive and fall is negative. Good, Alia. Now, once you know this, the sign convention is clear. Anshika, Doha,
For
Okay.
resistor, how do we know if which is higher, which is lower potential?
See, in cell we know that the larger one is higher and the lower one is the bigger line is higher potential, the smaller line is lower potential. Okay. In resistor, we know it by the direction of current. Current always flows from higher to lower potential. So just look at the direction of current and you can decide where is higher and which end is at lower potential. Got this, Nabil?
Yes, sir.
Next exam. Okay, these are the 4 cases that we use. Now let's see what does Kirchhoff voltage law says. The voltage law says if you have a circuit, you have a closed circuit, you should have a closed circuit to apply this law. This cell have some EMF E1. This is resistance R1. This EMF is E2. This resistance is R2. And this is how the current is flowing. And don't worry about the direction of current. We'll discuss it later how to decide the direction of current. Current is I, huh? Everywhere current is I. Now, first of all, Mehraj will tell me, Mehraj, how many voltages are there? We need to add voltages. Now, how many voltages are there?
So 2 E1 and E2.
2 E1, E2. And what about IR1 and IR2? Aren't they voltages?
The resistance aren't the resistances.
But you have voltage across resistance IR1. You have voltage across this resistor IR2. How many voltages you have?
The 4 to then total.
4. Total 4 voltages. So the Kirchhoff voltage law says the algebraic sum of all these 4 voltages is 0. You have to add them up and you write 0. But to add them up, you have to follow the sign convention. Now to add these voltages, you have to go in a particular sequence. You will either go in clockwise sequence or in anti-clockwise sequence. There is no other option. A, B, C, D is the name of the loop. It's your choice. You can go clockwise or you can go anti-clockwise. It's your choice. So I'm going in clockwise direction. This is the direction of my motion. To add these voltage, we will go in a particular sequence. That sequence can be clockwise or that sequence can be anti-clockwise. So we go in the clockwise sequence. This clockwise sequence. And while means we will go from A to B, then we'll go from B to C, then we'll go from C to A, then we'll come back to. Now, when we are moving from A to B, so from where we are moving from higher to lower potential or lower to higher?
Higher to lower.
Yes, everyone. Lower to higher or higher to lower? Which is correct?
Yes.
Yes, this is at higher potential, this is at lower potential. We are going from higher to lower potential. So when we go from higher to lower potential, voltage is positive or negative?
Negative.
Negative. So it will be minus of E1. Nabil Khan, look, this R1. What is the voltage across R1? Nabil Khan. Nabil, current I is flowing from here. The resistance is R1. What is the voltage across this R1? Nabil Khan. You're not in class, huh? See, if you are not responding, then as a punishment, I'll ask you to open your video. Nabil Khan, are you in class? Mohammad Saifullah, what is the voltage across this R1? Saifullah, what is the voltage across R1? I'm asking voltage across this. How much?
Yes, IR.
IR1, right?
Yes.
See, the current is IR. Now we have to decide whether this voltage is positive or negative. To decide this, you can refer this thing. Like when you go in the direction of current, the voltage is negative. When you go in a direction opposite to that of current, the voltage becomes positive. If you go in the direction of current, then voltage is negative. When you go in a direction opposite that of current, your voltage would be positive. So here, current is going from B to C. We are also moving from B to C. Voltage will be positive or negative, Saifullah?
Negative.
Negative. So it's minus of IR. Next, let's move from C to D. When we go from C to D, this is the cell, Kinza. When we go from C to D, we are moving from higher to lower or lower to higher?
Higher to lower.
So it will be positive or negative?
Positive. No, negative.
Negative. Higher to lower, fall, it's negative. Minus. Arpit, we are going from D to A.
Plus
Are
IR2.
we are going in the direction of current or in opposite direction?
It is in opposite.
Opposite. Aankh khol ke dekh, Arpit. We're going from D to A. We're going in the direction of current or in opposite direction?
Sir, in the direction.
I'm going from D to A. Current is also in D to A. We are going in the direction of current. So, Anshika, if we go in the direction of current, then voltage is positive or negative?
So positive.
Positive. Okay, Anshika, just go through this thing. Here we are going in the direction of current. Current is to the right. Motion is also to the right. Its voltage is positive or negative?
Sir, it is negative.
Negative. So here from D to A, you're going in the direction of current. So the voltage across R2 will be positive or negative?
Sir, it will be negative.
And what would be the voltage across R2?
Sir,
IR2.
negative IR2.
Which is equal to 0. This is Kirchhoff Voltage Law. It says algebraic sum of all the voltages in a closed loop is 0. Clear?
Yes, sir.
Yes, sir.
Now, the philosophy behind this law, this is based on conservation of energy. So how this equation represents conservation of energy? So listen first. See, voltage represents energy. Energy is voltage multiplied by charge. So if you are writing voltage, that means you are representing energy. In a circuit, you have two types of elements. Some elements give energy, provide energy to the circuit. Those elements are like those cells which are discharging. And then you have some elements which are consuming that energy. Those elements are resistors, bulbs, cells which are charging. So these are those elements which are consuming the energy. And the cell which is discharging is the element which is providing the energy. So when you say that algebraic sum of all voltages is 0, then you say that the energy provided by a cell is equal to the energy consumed by other elements. So this is how the energy is conserved. Like if there is a cell which is discharging, it provides 100 joules of energy. Then you have circuit elements which are consuming 100 joules of energy, so that the energy will remain conserved. Is it clear?
Yes, sir.
Fine, great. So this is Kirchhoff Voltage Law. And if you know these two laws, then you can solve any circuit of resistors. A very simple circuit which have two resistors in series, and a very complex circuits which have multiple resistors and multiple cells. You can solve each and every circuit if you know these two Kirchhoff laws. So you have written the first law. Just note down the second law, and then we will start the numericals. We'll start the questions. While taking notes, if you have any doubt, just discuss with me. Kirchhoff law is a very important topic for both your entrance exams and your school exams also.
Sir, this law is only applicable for series circuits.
For?
Only for series circuits.
For circuits?
Series circuits.
No, not just series circuit, for any type of circuit that you can think of. Series, parallel, combination of series and parallel. Circuits which are neither series nor parallel. Every type of circuit you can use Kirchhoff law. There is no limitation of this.
Sir, Wheatstone bridge also.
Okay, sir.
Yes, Wheatstone bridge also. Balanced as well as unbalanced Wheatstone bridge. See, whatever we learn in series and parallel combination till now, that they were tricks. They are not laws. They're applicable in some cases and they're not applicable in many cases. They are not laws, they are just tricks.
Can you
Scroll.
Up, sir, not down.
It's okay. Up.
Yes, sir.
This one, Miraj?
Yes, sir. This I1, I2, and I.
This one?
Yes, sir. Yes, sir. Thank you.
Tell me once you have written. I'll scroll it down.
Yes, sir. I've written this. No, no, sir.
Can you people just switch on your videos? Because once you open your video, now your concentration level will be better. Like there is no difference in online and offline class if your video is open. The difference between online and offline is just the pressure of teachers. Like in your offline classes, when you are in my classroom, there's a pressure that I'm there. So you can't take things leniently. Yeah. But in online class, the videos of I can't see you. So also I have started, I always use the focus mode. So when I start focus mode, your video will not come in recording. No one else than me can see your video. So only me, I can see your video. It will help you, like it will help you in improving your concentration level. Like if you are from people who can't concentrate in online classes, then you should just open your video. You'll have that psychological pressure, okay, someone is watching me.
Scroll.
And this video will not come into any recording. You even can't see one each another one.
Scroll up, sir.
Up. So if you can switch on your videos now, then I will instead of this writing pad, I will come to my whiteboard. I can experiment with those things. And Zoom offer very good this background options. Now you can blur your background, so don't even have to worry about the background thing.
Scroll.
Those who have concentration issues in online classes should switch on their videos, and the rest leave to you. Nabil Khan, Arvind class. Nabil.
Scroll.
Nabil, why were you not responding earlier?
Sir, little more.
It's okay. Nabil, switch on your video. हाँ? मुझे शक है तुम इधर उधर कुछ कर रहे हो. And Nabil, always use mic. Huh? Like this chat thing doesn't work in a live class.
Scroll.
Okay.
Sir, 1 second, can you scroll up?
Yes.
Okay.
Okay, Seth. Nabil, are you getting this Kirchhoff law?
Yes, sir.
Tell me if you stuck somewhere. Huh? This is something very, very important. Like in if chapter number 3, you ask me to pick some 3 important topics, then Kirchhoff law will be one of them. It's very, very important.
Okay.
Kinza, any doubt?
No, sir.
Minashi,
No, sir.
can I scroll it now?
Just a second, sir. Yes, sir.
Sir, please scroll a little bit, sir. I have it.
Okay, now let's discuss some other things. So what do you think, this equation should depends upon the direction of loop, or this equation should be independent of the direction of loop? What do people think? The equation that we wrote here, this equation, this should depends upon the loop or it should be independent?
It is dependent on the.
Sir, it
Should
is
be
dependent.
See, if it depends upon the direction of the loop, then in numerical, he have to mention which loop you have to choose, right? If it depends upon it, then you can't solve a circuit properly. The question, it will be like, so you have a circuit having some resistors in series and parallel. And if through a clockwise loop, you're getting some other answer, through an anti-clockwise loop, you're getting another answer, that means there is some flaw in the law. If this law is flawless, that means it should be independent of the direction of loop. It doesn't matter what direction of loop you choose. The equation will remain same. Let's check this thing. So let's take this loop as an anti-clockwise sense. This is anti-clockwise. This is anti-clockwise. So we'll tell, let's start with Kinza. It's the first class of Kinza with us. So let's start with Kinza only. Yes, Kinza, tell me, we are going from B to A. This EMF of the cell, it's rise or fall in potential?
Rise in potential.
Rise in potential. It should be negative or positive?
Positive.
Positive, very good. Then we come from to A to D. It will be rise or fall? You're going from A to D. Okay, so you have resistor. So let's do it in this way. We are going from higher to lower potential or lower to we are going in the direction of current or a direction opposite to that of current? A to D, Kinza.
Direction opposite.
Yeah, we are going from B to A and then we are going from A to D, and current is going upwards. So we're going in a direction opposite to that of current. So voltage should be positive or it should be negative?
Positive.
Positive, very good. It's IR2. Good. Let's come to this cell and let's ask someone else to do the rest of the calculation. Unib, what about this cell? We are going from D to C. Rise, fall?
Sir, rise.
Positive, negative?
Positive.
Positive. Nabil Khan, when we go from D to C, The EMF of the cell, it's rise or fall?
It rises.
Rise, positive, negative?
Negative.
Rise. See, just
In the
Positive.
opposite direction. Okay.
no, no. See, when you have cell, then we don't see direction. We just see you are moving from lower to higher or higher to lower. You're going from negative to positive. It's rise or fall? It's rise, na?
It's rise.
So it should be positive.
Yeah.
Okay, Nabil, just tell me this thing. You're going from C to D. You're going in the direction of current or opposite to the direction of current?
Opposite direction.
So voltage across the resistor will be positive or negative?
Negative.
Negative. Negative. Just look at this thing. See here. You're going in a direction opposite to that of current. Current is rightwards. You're going to the left hand side. Voltage was positive or negative?
Positive.
So here it should be
Positive.
positive. ये क्या हो गया? Alia, these two equations are same or different? Different equations, okay? Alia don't have mathematics, huh? Different equations. Arpit, what do you think? These two equations are same or different?
Sir, same.
Same equation. See, if you take negative sign, negative common from this equation, then you will get E1 plus IR1 plus E2 plus IR2, which is equal to 0. You can take this -1 to the right hand side, it will become 0. I'll be left with this thing one. So this and this are same equations. Or you can multiply this equation with the minus sign. Like we can always multiply equation, both the sides of the equation with the same thing. Na? If I multiply this equation with the minus sign, then what you will get minus E1 minus IR2 minus E2. Sorry, it will be IR2 or it will be IR1? It will be IR. Minus IR1 is equal to 0. So these two equations are different or same equation, Alia? Same equations. So it does not matter which loop you choose. The equations are independent of the choice of you. Fine. So Kirchhoff law is very, very flexible. It's also does not depend upon the direction of current. Whatever direction you choose, you will get the right answer. This is the good thing about mathematician. Like when a mathematician gives something, it's very, very symmetrical thing. Miraj, you switch off your video. Is it clear, this thing? If we change the direction of loop, that there is no effect on the equation.
Yes, sir. Yes, sir.
Okay, note it down. So I'm deleting it. It will create confusion. I just want to show that even if you change the direction, the equation will not change. The equation remains. X plus y equal to 0 and minus x minus y equal to 0 are the same equations. They are not two different equations. Okay, now let's move on to questions. Let's do some questions on this concept. See, the questions of Kirchhoff laws are usually very lengthy. So what I will do is I will do one question, and in that one single numerical, we will check all possibilities. So this is the circuit. Let's make a big circuit. So this is your circuit. Huh? This is the circuit. You're supposed to just draw the circuit. I'm writing what you're supposed to, what you will calculate. Calculate first part. Current through each resistor. Second part. Voltage across each resistor. Third, power dissipated across 5 ohm resistor. Fourth. This 5 ohm. Potential difference between A and F. We also need potential difference between B and C. So this is extreme. These are the type of questions then one can ask in a circuit. He can ask you to calculate current, voltage, power, potential difference between two random points. He can't ask you to calculate R equivalent. See, when you have two cells, then you can't calculate equivalent resistance. The concept of equivalent resistance doesn't make sense if you have multiple cells. This thing makes sense if you have a single cell. Right, Miraj?
Yes, sir.
Just note it down. We'll start the calculations.
Sir, could you show the last fifth part?
Okay, let's move further. Solution. So we'll do it in steps. The first step. To solve any circuit using Kirchhoff law, the first step is you take division of current. Step 1. Step 1 is division of current. Take division of current. Division of current means, for division of current means you have to decide through which cell what current will pass. So you can start from any cell. It's your choice. You can start from any cell. I start from this cell. Let's say some current I1 starts from this cell of 2 volt. So the first thing is this current will, when this current leave this cell, it will get divided into the entire circuit. But after passing through entire circuit, it will divide. But finally, you should get back the same current I1 that will enter in the cell. So the current which comes out of the cell will enter in the cell. That's the first rule. So in the division of current, always keep in mind that current will enter. Same current will go out in it. The first thing. Now current will divide. Let's go to on every junction. At junction A, will current divide over this junction? Is there any branching at point A? Branching hai? Nahi hai. Is there any branching at point A?
Sir, yes, sir.
No.
Yes,
D
sir.
point.
There's no branching at A. See, branch will be this way, na? No
D
branch.
point, sir. D
Not
point.
at D is branching. I'm asking about point A.
No, sir. No.
There's no
branch.
branching at
branch.
point A. No branching. So same current will go over here also. I1 will go over here. Is there any branching at point D? Yes, you have two branches. See, if you have difficulty in division of current, then assume current as a liquid which is flowing and the wire as the pipes. You have branches, right? So the current will divide. Some current I2 pass through this 5 ohm resistor. Then how much is left? If out of I1, I2 pass through this resistor, how much is left? Anshika, how much current is left if I2?
I1 minus I2.
I1 minus I2. This current will pass through this cell, it will go come here. This I1, not I1, this I2 is coming from here. See, at point E, there is no branching, so current will not divide. Here, no branching, so current will not divide. Same I1 minus I2 is coming here. Now, Nabil Khan will tell. Nabil Khan, at point C, how many currents are entering? Yes, Nabil.
Two.
Two currents are entering. So they should combine, right? If two currents are entering in
Yeah.
the junction, then they should combine. Which two currents will combine, Nabil?
I2 and I1 minus.
So I should add them up. They are combining. I will add them up. No, sorry. It's I1 minus I2.
I2 plus I1 minus.
So I2 will cancel I2 and left with I1. And this is what we were expecting. We were expecting the same current will enter in the cell also. So if here you get I1, that means your calculations are correct. But instead of I1, if you get I3 or you get I2 or you get some combination of I1 and I2, that would mean there's some you're doing some mistake while dividing the current in the circuit. Is this division clear?
Yes, sir.
Yes, sir.
Minashi, Kinza, Hishma,
Yes, sir.
Yes, sir.
Yashika, clear?
Yes, sir.
Okay, Yashika, just tell me. Is this division unique or we can have more divisions? Or we can have more different type of divisions in the same circuit? Yashika, is this division of current unique or we can have different types of divisions in the same circuit?
So
Yashika,
what does different division mean? Matlab?
different division means कि मैं यहाँ कह रहा हूँ, I'm saying that some current I2 is flowing through this resistor, then some other current will flow this resistor. Or instead of starting with this cell, we can start with this cell. I'm saying that the current through this 5 ohm resistor is I1 minus I2. Is it possible that current through this 5 ohm resistor could be I2 or I5 or I3, something else?
No, sir.
There could be many type of divisions. There could be different divisions also. Say, let's see one more type of division. There are 5-6 possibilities here.
So the current will be same, right?
No,
So the value will also change.
no, the value will not change. But the variables that you are taking will change. End result will remain same. The numerical value that we will calculate will remain same. But individual values can change. Individual values can change. This is 2 volt, this is 1 ohm, this is 5 ohm, this is 2 ohm, this is cell of 5 volt. See, there is one option that this 2 volt is not a special cell. We can start from this 5 volt cell also. There's nothing special about this 2 volt. We can start with this 5 volt also. When we start with 5 volt, currents, let's say this is some I1. I1 will go here, I1 will go here, I1 will go here. Kinza, will it divide now?
Yes, sir.
We'll divide into two parts. Some I2 goes here. Some I1 minus I2 goes here. So this is I1 minus I2 again. This is I1 minus I2 again. You have I2 again here. See, they gets combined, and when they combine, then you have I1 minus I2 plus I2. It gets cancelled out the same current. You're getting the different current, right? Earlier it was I1 minus I2. Now you have I1. So you can have many type of divisions, but when you solve these equations, you will get the same answer. Answer will not change. That's the beauty of this Kirchhoff law. You can think of few more type of divisions, right? Instead of taking current to the right hand side, you can say, oh no, I will take current to the left hand side. There's also a possibility. You can have 4 or 5 types of divisions, but if your division is correct, the numerical value will be same. And how will you decide your division is correct? By this statement: current that comes out of the cell should enter. I1 current goes out of the cell, so I1 should enter. Is it clear, everyone? Nabil Khan, Noha, Anshika.
Yes, sir.
Yes.
Yes, sir. Yes, sir.
Clear. Okay, now do it. Just note this division of current. Note down this division of current. And it would be better if you try to do that division on yourself. Huh? Instead of copying and pasting everything, just try to do it yourself. Because the major part in solving circuits using Kirchhoff law is this division of current. If you can do division of current, then you know everything. By the way, Kirchhoff law is also applicable for capacitors. There are certain circuits in capacitors which can't be solved by a normal series and parallel combination. So you use this thing, Kirchhoff law, for those circuits also. Just note it down somewhere. The division is not unique. You can have many type of divisions. And from the next class onwards, I will prefer if you can switch on your videos. Huh? I'm assuring you again that these recordings, these videos will not come into in the recordings, and no one else can see you than me. Only the host can see. Even you people can't see each other. Or you can see, no, you can't. No? Just focus mode is on. So there's no issue with the privacy. If you want, Learnivio can give that you in writing. But if you switch on your videos, that will be good for your concentration level. Huh? And there are many things that teacher decide through the face expressions of the students. Okay, noted this thing, this division of current?
Yes, sir.
Okay. So let's stop here. We will continue this in the next week. So in the next week, we will finish this current electricity. I need just 2 more lectures and actually 1 more lecture and we can finish this current electricity. We'll finish this by next week and we'll start magnetics. Now let's come to that JE and NEET sessions, revisions of JE and NEET thing. We'll do this numerical in the next class. Huh? Do these steps in the next class. Okay, let's come to that JE NEET revision. So what topic we were doing in that revision class? we have discussed capacitors, right? See, in capacitors, there is just one topic, this cylindrical capacitor that we discussed yesterday, which is not in NCRT but can be asked in your exams, NEET or JEE exams. Else than this cylindrical capacitor, there is no topic which is not in NCRT and is in JEE syllabus. But yes, the standard of numericals is always different. So let's discuss few numericals. Just give me 1 second. Let me add some numericals from the system. Just give me 1 minute.
Sir, it's lagging.
Sorry. Sorry. Yes, Jasola, you're saying something?
Sir, it isn't visible.
Yes, I'm just taking screenshot of the question, sir. I'm just finding the screenshot of the question. So basically, I'm just finding those type of questions which we have not yet discussed. Yeah. See, in capacitors, you won't find any theory topic that is not in NCRT or we have not discussed. But yes, in JEE, you can get some tricky questions. So let's have a look at this question. Let's do this question. First of all, just note down this question. And while you are noting it, writing this question, just make a rough sketch, the rough sketch of the given terms. What are the quantities which are given. So Kinza, this is how we do JEE and NEET things. See, the difference between your CBSE syllabus and your JEE syllabus is just 18%. That's it. So for the first 1.5 hours, we discuss topics which are in NCRT. And then in the next half an hour, we revise the previous topics, keeping that JEE and NEET thing in mind. So it will help you even in revision also. So doing the same thing twice. Yes, everyone, have you written this question?
Just a minute, sir.
And if someone from you doesn't have plan for JEE NEET, but this will still help you in improving your numerical solving skills. In this half an hour, I'll just try to teach you like how to think. Yes. Written, shall we start the calculations?
Yes, sir.
So first of all, let's decide which topic of capacitor is this numerical using. See, this numerical says, first of all, the switch is at position A, and then you turn it towards the position B. There is some loss in energy. So what do you think, which topic of capacitance is this particular question using?
Energy of a capacitor.
Energy of capacitor is one thing. Another topic? See, when you have questions of JEE and NEET, those questions does not include a single topic. It includes multiple topics. One is energy of capacitor. Very good. Another? Noha? The another topic is sharing of capacitor. We did sharing of capacitor, right? The common potential was C1 V1 plus C2 V2 by C1 plus C2. Just turn your notes, huh? Just keep your notes of capacitor in front of you. Just turn pages and go through this thing. Sharing of capacitor. So it's using the sharing of capacitor thing. See, first of all, this C is connected to the cell. This C is not connected to the cell. That means only this C will have some energy. The first capacitor will have energy. So the initial, and this is connected to a cell of EMF E. Huh? So the energy will be half C E square. But see, in option, there is no C. There is, sorry, in option, there is no E. How will you eliminate E? It's always Q. Can you eliminate E in terms of Q? You know this, na? Q is C. So you can say that your E is Q by C. So you can easily eliminate E, right? Instead of E, so you can write this thing as it's Q by C. Yeah? So you can say that initial energy is half C into Q square by C square. So C will cancel this square. It's Q square divided by 2C now. This is the initial energy. Is it clear?
Sir,
Yes,
how do you get half CE square, sir?
This is the expression of energy stored in capacitor. It's, this topic is.
Yes, sir, yes, sir. And okay, sir.
Now you have this capacitor. Next, you connect it to this capacitor. So you disconnected it from here and you connected it here. When you connected here, you are sharing these two capacitors. When you share these two capacitors, you have a common potential. What's the expression of that common potential? C1
V1 V1
V1 plus C2 V2. So C1 is C. What is V1? Initially, it was connected with this cell, na? So V1 is E.
E.
What is C2? C2 is C, not C, it's 3C, na? Yeah, it's 3C. Sorry. It's 3C. And it's not connected, it was not connected to any cell initially. So the voltage across this is 0. Divided by C1 plus C2. So this is C plus 3C, which is 4.
4C.
So the common voltage is CE by 4C. C will cancel this C. This is E by 4. This is the common voltage. Huh? So once you have common voltage, can you calculate energy, final energy? You can always calculate final energy, right? How do you calculate final energy? It will be half C. What is the voltage across this capacitor now? The voltage is E by 4. So it will be E by 4 square plus it's half into 3C. Then voltage is again E by 4. It's E by 4 square. So it's half C. It's E square by 16 plus 3C by 2. It's E square by 16. So if I take this as common, this will be like, and denominator will have 32. And this will be 3 and 1 4. 4C E square by 32. And if you cancel them out, 8, it's C E square by 8. And if you want, you can remove C using this equation earlier. Q is equal to C. So you can write E as Q by C1. So when you put it here, your final energy will comes out to be C by 8 into E, which is Q square by C square. So this is Q square by 8C. So initially this was the energy. Finally, this is the energy. See, energy is decreasing. So the loss in energy will be initial energy minus the final energy. Initial energy is Q square by 2C. Final energy is Q square by 8C. When we subtract them, it's AC, it's 4q square minus q square. It comes out to be 3q square by 8c. Is there any option of 3q square by 8c? Yes, this is an option. Yashika, Uneeb, Noha, Miraj, clear?
Yes.
Yes,
Sir.
sir.
Arpit,
Yes, sir.
do it. And don't just copy these calculations. Try to do it on yourself. I find another question. Tell me once you have written, I will come to the next numerical.
Done, sir.
It's okay. Note down the next question. Don't write options. It will take your time. Just note down the question. Okay, let's start with this question.
So wait.
Sure. Okay, Alia. See, it's a parallel plate capacitor that has some plate area. The separation between them is D. And the dielectric constant varies as Kx is K1 plus alpha x. So here the dielectric constant is not constant. The electric constant is variable. And the electric constant varies along this direction. So if your dielectric constant is constant, then you can simply write your Kc as K epsilon or d by d. It's a simple thing. But if your dielectric constant is variable, then what we do is we take a small section here, a very small strip. We call the thickness of the strip as dx. Call that the thickness of the strip is dx. The area of the strip will be A only, the area of the plates only. We'll first calculate capacitance of this element. So the capacitance of this element will be DC, which is K epsilon naught A divided by the separation between the plates is DC. K, we know that is a variable K1 plus alpha x. Now we can take similar strips. Now I can take one more strip here. And I can take one more strip here. Can you tell me how these all strips, how these all elemental capacitors are connected? They're either connected in series or in parallel. Yashika, they are connected in series or in parallel?
The series.
Series. See, when we were doing a series and parallel combination of capacitors in some circuits, I have told you, if separation divides, that means they are in series. If area divides, then they are in parallel. Here, separation divides, that means they are in series. So this is DC. So there are many DC capacitors which are connected in series. So for 1 by C equivalent, what should we do? We should add it like in this way: 1 by DC plus 1 by DC, and just keep on adding it. Or instead, obviously we can't add in this way, so we will integrate 1 by DC. What is DC? This is it. So we will integrate it dx. 1 by DC means we'll take reciprocal of it, dx by K epsilon naught A. And what is the limit? The limit is from this plate to this plate. Separation between them is, I guess it's D, na? Yes, it's D. So it's 0 to D. Now we have K, which is 1 plus alpha x. So 1 by C equivalent is, it's 0 to D, 1 by K, which is 1 plus alpha x. See, in JEE 2020, this was one of the toughest questions. 5 questions were very tough, and this was one of them. 1 plus alpha x. It's there's 1 K also, no? Then you have area, and then you have dx. See, this K is constant, this A is constant. You can take constant outside this integral. So we'll get it 0 to D, 1 by Ka is bahar, and you have dx over 1 plus alpha x. Now you need integral of 1 plus alpha x. The integral of 1 by alpha x is, this is 1 by Ka. The integral is log of 1 plus alpha x and 1 by alpha. 1 by alpha will come outside. This is the integral. When you integrate it, this is 1 by x type functions, you take log. The term which is in multiple with x, which is alpha, you take it outside. So this is the integral, 1 by, and the limit is obviously from 0 to D. So it's 1 by alpha Ka. Now let's substitute the limit. When you put x, D instead of x, 1 plus alpha D, minus its log of, it's 1 plus alpha into 0. See, the weightage of these type of questions is not 100%, it's 20-25%. 1 plus alpha D minus its log of 1, that's log. And log 1 is 0. So you have 1 by alpha Ka, its log of 1 plus alpha D. Now this term is 0 and log 1 is 0. So this is 1 by C equivalent. But you don't need 1 by C equivalent. You need C equivalent. You need C equivalent. Huh? Now, if you look at the options, there is no option is log. That means he have open this log series. You open the log series. So when you open the log series, you get beyond this is just mathematics. Log of 1 plus x, you can write log of 1 plus x as 1 minus x square, like no, not 1, it's x minus x square by 2 factorial and so on. So we can write this as 1 by c equivalent is 1 by alpha ka. Log of 1 plus alpha d is alpha d minus alpha square d square divided by 2. Now, if you want, you can take this alpha d as common. You can take it as outside. It's alpha d by alpha ka 1 minus it's alpha d divided by 2. Alpha will cancel this alpha and you will have 1 by c equivalent is d by ka. You can take 2 as LCM. It's 2 minus alpha d now. You can take reciprocal of this thing. Now, c equivalent will be it's ka by d. It's 2 by 2 minus alpha. This is the answer. So this is how we solve if you have dielectric constant which is variable. There is no option still matching. That means you want to simplify it further. You can simplify it further. Like you can write this as ka by d. It's 2. Then you can write it's 2 minus alpha d to the power minus 1. You can write this as it's twice of ka by d. This is 2, just multiplied negative with here. It's 2 plus alpha d. This is binomial expansion basically. If you have 1 plus x to the power n, then you can write this as 1 plus nx also. So I use that thing. I multiplied minus 1 here, so it becomes plus. So this is C equivalent. Note it down. So these are the steps if k is variable. See, these type of questions have small weightage, 20, 15% weightage. JEE have 25 questions. If out of 25, you do 15 questions correct, you will get a very good percentile. And in NEET, you have 45 questions. Out of 45, 25 are easy. 10 are just, you can say that average. And the rest of the 10 are like these numericals. They are really tough. So for the NEET aspirants who want to score, like who are worried about their, what do you say, rank, the rankers, they solve previous year's JEE. Like Aska, I was giving you example a week earlier. Aska, we were training Aska for NEET, and then she appeared for JEE and scored 99 percentile in JEE also. Her NEET exam is also good, so maybe she will have options of choosing BTech from IIT and MBBS from some good institute. If your numerical solving skills are good, then entrance won't be an issue for you. Can I scroll it further?
Yes, sir.
Yes, sir. So how did you got the alpha score?
Sorry?
How did you took alpha score?
Alpha outside, you're saying?
Yes.
Okay. This is the formula of integration. Like if you are integrating a function of the form 1 plus some constant k times x dx. So the formula is it's log of 1 plus kx divided by k. Whatever the constant that you are using with this x will come outside. Okay. See, majority of questions that comes in your entrance JEE and NEET exams are based on your NCERT syllabus. So the thing that we are doing for 1.5 hours doesn't mean that won't come in JEE. Those questions will be a major part of your JEE exam, JEE or NEET exams. But yes, there are few tricky questions left that we discuss in the next half an hour. Can I scroll it now? Nabil Ahmed, after the class, please stay for 1-2 minutes. I need to discuss you something regarding your maths classes.
Yes, sir.
Sorry, Savula?
Can you scroll up?
Okay. See, if you're not planning for JEE and NEET exam, then you should sit for SAT. Huh? You should sit for SAT. Else than English, everything will be easy. Like you have to prepare for English on your own. Your maths, physics, reasoning, that I can take care of. Whatever you are doing in your class 11th and 12th, that's more than enough for your SAT, physics, and maths thing. The only thing that you should worry about is your English.
Sir, is this the final answer?
Yeah, this is the final answer.
So, but all the terms in the options are epsilon naught. We're not having epsilon naught.
I missed epsilon naught. I missed epsilon. This was epsilon naught A by D, na? I missed epsilon naught and everything. So this will be epsilon naught in that numerator. It was there. I just missed that term. See, to match the final answer, you may have to take some common. You may have to take this 2 as common. Written, everyone?
Yes.
So that binomial part, could you say again?
Yeah. See the binomial expression. This was class 11 maths. Huh? If you have 1 plus x to the power n, and if I say that x is very, very less than 1, then you can write this as 1 plus n x only. You have few more terms. But if this x is very small, then you can leave it at 1 plus n x only. So here, this is minus 1 power. So I multiply it with here. That's it. This is what I did. You can take common now. If you take common, this will be 1 plus alpha d by 2. And you can take this 2 as common here. Okay, so we'll stop here. In the next class, we'll do few more numericals on capacitors, and then we will start after capacitors, we'll start the revision of current electricity. So till next class, we'll finish current electricity for CBSE, and then we'll start the revision of current electricity, keeping the JEE and NEET in mind. Okay, so let's stop here. We'll continue in the next class. Huh? Okay, bye. Thank you.
Thank you, sir.
Okay, bye.